If you ask someone in Britain to name the temperature that changed how the country thinks about heat, most people will give you the same answer. 40.3 degrees Celsius. Coningsby, Lincolnshire, the 19th of July 2022. The day the United Kingdom passed 40 degrees for the first time in recorded history, runways buckled and parts of London caught fire. That is the number in the national memory, and it deserves to be. But it is not the number I want to talk about, because the temperature that actually changed the picture arrived 3 summers later, and it was almost 5 degrees cooler. In the summer of 2025, the highest temperature recorded anywhere in the United Kingdom was 35.8 degrees at Faversham in Kent. A hot day, an unremarkable one by recent standards, nowhere near a record. And summer 2025 was the hottest summer the United Kingdom has ever recorded. Mean temperature from the 1st of June to the 31st of August, 16.10 degrees. That beat the previous record of 1576, set in 2018. And it pushed the summer of 1976, the summer that is a cultural reference point in Britain. The one your parents or grandparents still talk about, out of the top 5 entirely. No all-time heat records were set in 2025. Not one. And it was still the hottest summer in a series, going back to 1884. In the next 30 minutes, I'll explain how that is possible, why a record broken this way is more significant than one broken by a single dramatic afternoon, what actually drove it, why the overnight temperatures matter more than the daytime peaks for the thing that actually kills people, and what the attribution science says about how often Britain should now expect summers like this. I'll also be careful about what this does and does not mean, because heat is a subject where both the alarm and the dismissal tend to outrun the evidence. Let's start with what the record actually measures. When the Met Office says summer 2025 had a mean temperature of 16.10 degrees, that is not the hottest day, and it is not the average of the daily highs. It is the mean of maximum and minimum temperatures, averaged across every day of June, July, and August, and averaged across the whole country, from Cornwall to the north of Scotland. That last part matters enormously. A national mean has to include the cool places. It includes rainy Tuesdays in Aberdeen and gray mornings in Cumbria. Every mild, ordinary, unremarkable day and night in 3 months of British weather is in that number, which is why moving it is so hard. A single record afternoon barely touches a seasonal mean. One extraordinary day in 92 in one county out of many is a rounding error. The 40.3 degrees at Coningsby in 2022 is the most extreme temperature in British history, and summer 2022 sits 5th on the list of warmest summers, at 15.71 degrees, below 2003, below 2006, below 2018, and well below 2025. So there are 2 completely different ways to have a hot summer, and Britain has now experienced both within 4 years. The 2022 version is the spike. A short, violent, extraordinary event, a few days of unprecedented heat, dramatic, visible, frightening, and over quickly. The 2025 version is the plateau. No single day that anyone will remember. Instead, 3 months in which the temperature simply never really came down. I want to give you a sense of what that requires, because I do not think most people appreciate how strange it is. To lift a national seasonal mean by more than 1/3 of a degree above a record that had stood since 2018, you need warmth that is not just intense, but relentless. Daytime and nighttime, weekday and weekend, north and south, through cloudy spells and clear ones. The Met Office described exactly that, consistency of warmth, with temperatures remaining on the warmer side even outside the heat waves. And 2025 did have heat waves. Back-to-back ones. There were at least 3 across the season, with droughts and wildfires following them. But the record was not built by the heat waves. It was built by everything in between. Now 1976, because you cannot discuss British heat without it. The summer of 1976 occupies a place in the national memory that no meteorological statistic can dislodge. It was the summer of the drought, of standpipes in the street, of reservoirs drying to cracked mud, of a government appointing a minister for drought. If you speak to anyone in Britain over about 60 and mention hot weather, 1976 will come up within 2 minutes. It is now outside the top 5 warmest summers on record. I find that genuinely striking, and I want to be fair about why 1976 lodged in the memory the way it did, because the answer is not that people are misremembering. 1976 was exceptional in ways the mean temperature does not capture. It followed an exceptionally dry preceding year, so the drought was cumulative rather than seasonal. It produced a sustained run of consecutive days above 30 degrees in a country whose infrastructure had no expectation of such a thing. And crucially, it was an enormous outlier against the climate of its time. Set against the summers of the 1960s and early 1970s, 1976 was extraordinary. A freak event in a cool, damp island's climate. That is the real point. 1976 was not remembered because it was the hottest. It was remembered because of how far outside normal it sat. And what has changed since is not that Britain occasionally gets a hot summer. It is that normal moved. Here are the 5 warmest summers in the UK series, which begins in 1884, 2025 at 16. 10 degrees, 2018 at 15.76, 2006 at 15.75, 2003 at 15.74, and 2022 at 15.71. All 5 have occurred since the year 2000. In a record spanning more than 140 summers, the top 5 are clustered in the most recent quarter of it. That is not a pattern you get from natural variability arranging itself unluckily. That is a distribution that is shifted. And 2025 was not just a hot summer. It was a hot year, and that context changes how you read it. The Met Office confirmed 2025 as the UK's warmest year on record, with a mean temperature of 10.09 degrees, beating the 10.03 set only 3 years earlier in 2022. It was only the second year in the entire series in which the UK's annual mean exceeded 10 degrees. It was also the sunniest year on record, with 1,648, 5 hours of sunshine, more than 61 hours above the previous record from 2003. England and Scotland both recorded their warmest years ever. Wales and Northern Ireland their second warmest. Spring 2025 was the warmest on record. Summer 2025 was the warmest on record. Winter and autumn were both above average. Every month except January and September was warmer than average. In the 6 months from March to August, every single month ran at least a full degree above the 1991 to 2020 baseline. Since 2000, the UK annual mean temperature record has been broken 6 times: 2002, 2003, 2006, 2014, 2022, and 2025. All 10 of the warmest years on record have occurred within the past 2 decades, and 4 of the top 5 fall within the current decade. So what actually drove it? Met Office scientist Dr. Emily Carlisle identified 3 factors working together, and each one is worth understanding because they interact. The first was persistent high pressure. Anticyclones parked over or near the UK for extended periods, suppressing cloud formation, blocking Atlantic weather systems from coming through, and allowing sunshine to build heat day after day. That is also the explanation for the sunshine record. The same blocking pattern that keeps rain out lets light in. The second was unusually warm seas around the UK. This one is underappreciated by most people because it is invisible. Britain is an island, and its climate is dominated by the water around it. The sea has an enormous thermal mass, meaning it heats and cools far more slowly than land. When surrounding waters are warmer than usual, air masses arriving from any direction have to cross warm water first, and they arrive over land already warmed. Warm seas also suppress nighttime cooling, because the air over the coast cannot shed heat to a cold ocean that is no longer cold. The third was dry spring soils, and this is the one I find most interesting because it involves a feedback loop. When soil contains moisture, Incoming solar energy does two things. It warms the ground and it evaporates water. Evaporation consumes energy. That is why sweating cools you, and why a damp cloth on your forehead feels cold. Energy spent turning water into vapor is energy not spent raising the temperature. When soil is dry, there is no water to evaporate. All of the incoming energy goes into heating the ground, and the ground heats the air above it. So a dry spring produces hotter summer days, which dries the soil further, which produces hotter days still. Britain went into summer 2025 after its warmest and driest spring on record, which meant the ground was already primed. Carlyle summarized the combined effect precisely. These conditions created an environment where heat builds quickly and lingers. And she added the detail that is, to my mind, the most important sentence in the whole story. Both maximum and minimum temperatures were considerably above average. Minimum temperatures. The overnight lows. This is where the inversion I opened with actually pays off, so let me explain why nighttime temperature is the number that matters. The human body handles daytime heat reasonably well, for a while. You sweat, blood vessels near the skin dilate. The heart works harder to move blood to the surface where it can shed heat. It is a demanding process, and it costs the cardiovascular system real effort, but a healthy body can sustain it. What makes that survivable is the night. When the ambient temperature drops, the body finally sheds accumulated heat. The cardiovascular system stands down, and core temperature returns to baseline. Sleep is when the recovery happens. If the overnight temperature does not fall far enough, that recovery does not occur. The body starts the next day already carrying yesterday's heat load, with a cardiovascular system that has not rested. Do that for several consecutive nights and physiological strain accumulates. This is why heat mortality is not driven primarily by the peak temperature. It is driven by duration and by nighttime minimums. It is also why heat deaths concentrate among the elderly, people with existing cardiovascular or respiratory conditions, and people in housing that retains heat, top floor flats, buildings with poor ventilation, homes without any means of cooling. Which brings us to Britain's specific vulnerability, and it is an architectural one rather than a meteorological one. British housing is designed, and has been for centuries, to retain heat. Thick walls, small windows, minimal cross ventilation, and in recent decades, heavy insulation and airtight construction, driven by entirely sensible policies aimed at reducing winter heating costs and emissions. Air conditioning is rare in homes and uncommon in older workplaces and schools. Every one of those features is correct for a country whose principal climate risk is cold and damp. Every one of them is wrong for a sustained warm spell. A well-insulated house that will not let heat out is a house that becomes an oven over a 5-day warm period and does not cool at night. So a summer like 2025, no dramatic peak, but persistently warm days and warm nights over 3 months, is close to the worst-shaped heat event for the British housing stock. A single 40-degree afternoon is survivable in a brick house because the following night brings relief. 10 weeks of warm nights does not. That is the sense in which 2025 changed the picture. Not a new maximum. A new understanding that the dangerous variable was never the number on the thermometer at 3 in the afternoon. Now, the attribution science, because the Met Office did something here that deserves attention. Within days of the season ending, Met Office climate scientists ran a rapid attribution analysis using peer-reviewed methods and published the result. Their finding, a summer as hot as or hotter than 2025, is now around 70 times more likely than it would be in a natural climate without human greenhouse gas emissions. The head of climate attribution at the Met Office, Dr. Mark McCarthy, put the same finding in the form that I think communicates it best. In a natural climate, a summer like 2025 would have an expected return period of roughly 340 years. In the current climate, you would expect one roughly 1 year in 5. From a once in 3 centuries event to a once in 5 years event. For the annual record, the attribution figure was larger still. Human-induced climate change made the UK's record-breaking 2025 annual temperature approximately 260 times more likely. Let me be clear about what attribution studies can and cannot say, because this is frequently misrepresented in both directions. They do not say climate change caused a particular summer. Weather is always the product of specific atmospheric conditions on specific days, and those conditions were the high-pressure patterns and warm seas described earlier. What they do is compare probability. Climate models are run twice, once representing the real world with observed greenhouse gas concentrations, and once representing a counterfactual world without industrial emissions. You then count how often an event of the observed magnitude appears in each set. The ratio between those frequencies gives you the change in likelihood. It is a probabilistic statement, like saying that loading a die makes a 6 more likely without claiming any particular 6 was caused by the loading. That is a weaker claim than the headlines sometimes suggest, and a far stronger one than the dismissal that you cannot attribute any individual event. And McCarthy added a point that deserves more attention than it received. The analysis suggests that while 2025 set a record, substantially hotter summers are plausible in the current and near future climate. 16.1 degrees is not a ceiling. It is a new entry near the top of a distribution that has room above it. There is one more number that reframes all of this, and it is the least dramatic thing in the report. During the period 1991 to 2020, the UK's mean summer temperature was 14.59 degrees. For the period 1961 to 1990, it was 0.8 degrees lower, 0.8 of a degree between two 30-year baselines. That sounds trivial, and it is the whole story. Because when the Met Office says a summer was 1.51 degrees above average, the average being referenced is the 1991 to 2020 period, which is already 0, 8 degrees warmer than the baseline used a generation earlier. The reference point moves. Every time the standard 30-year climate normal is updated, today's warmth gets measured against a warmer yardstick, which makes each new record look less extreme than it is against a longer record. That is not manipulation. Using recent normals is standard practice and useful for forecasting. But it means the phrase above average conceals a moving floor, and it is why comparing 2025 to 1976 by anomaly rather than by absolute temperature understates how far things have traveled. So let me be direct about what this does not mean. It does not mean Britain is becoming a hot country. The mean summer temperature is 16.1 degrees. That is a pleasant temperate summer by most of the world's standards, and it remains substantially cooler than southern Europe. British summers are still frequently gray, and it still rains. It does not mean every hot summer is climate change. Natural variability is large, and the drivers in 2025, blocking high pressure, warm surrounding seas, dry soils, are ordinary meteorological phenomena that have always occurred. What has changed is the baseline they operate on top of, and the frequency with which the combination produces a record. It does not mean 2025 was catastrophic. The heat brought droughts and wildfires and real strain, but it did not produce a national emergency on the scale of the 2022 spike, when infrastructure failed visibly. And this was not confined to Britain. Met Iran reported that summer 2025 was also Ireland's warmest on record in a dataset going back to 1900, driven by the same combination of dry soils, high pressure, heat domes over mainland Europe, and warm surrounding sea surface temperatures. That regional consistency is itself evidence that this was a large-scale pattern rather than a local anomaly. Here is what I'll be watching. The first is overnight minimum temperatures rather than daily maxima. The Met Office publishes both. If you want the single most useful indicator of whether British summers are becoming genuinely dangerous rather than merely uncomfortable, it is the number of consecutive nights above about 20 degrees, which is the rough threshold above which sleep and cardiovascular recovery are meaningfully impaired. The second is sea surface temperatures around the UK through spring. Warm surrounding waters were one of the three drivers in 2025, and they are measurable months in advance of the summer they influence. The third is spring soil moisture. A dry spring loads the dice for a hot summer through the evaporation feedback described earlier. Watching spring rainfall totals tells you something real about the summer that follows. The fourth is building regulations and retrofit policy. Britain's heat vulnerability is a housing problem, and the relevant question is whether overheating standards for new build and retrofit are strengthened. That is an unglamorous policy area that will do more for heat mortality than any forecast improvement. And the fifth is whether the record stands. Given that 2018's record lasted 7 years and 2022's annual record lasted 3, and given McCarthy's point that substantially hotter summers are plausible now, the useful question is not whether 16.10 degrees will be beaten, but how soon. I want to end where I began. In July 2022, Britain hit 40.3 degrees for the first time, and the country reacted the way you would expect, with alarm, with headlines, with a genuine sense that something had shifted. That reaction was correct. 3 summers later, the hottest day of the year was 35.8 degrees in a corner of Kent, and almost nobody noticed, because it was not a record, and there was nothing dramatic about it. And that summer turned out to be the hottest the United Kingdom has ever recorded. Hotter than 2018, hotter than 2003, hotter than the summer of 1976 that an entire generation still measures heat against. It got there without a single day anyone will remember. It got there because the temperature simply did not come down, not in the afternoons, and more importantly, not at night, for 3 months, across a country built almost entirely to keep heat in. The number that changed things was never the one at the top of the thermometer. It was 1610, and it is an average. We'll be watching the overnight minimums.